In this video, we are going to discuss equation of plane in 3 dimensions. There is a plane in which there is a point A whose distance from origin is d. There is a unit vector n cap normal to this plane, and we have an arbitrary point P on this plane whose position vector is r bar. So with the help of this information, we can write a normal form of vector equation of this plane as r bar dot n cap equals d. Let us see in detail how this equation comes into being, and we will study many more equations of planes in 3 dimension. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. So we have a plane here. A point A is given on this plane and its distance from origin is d. Position vector of point A is a bar. There is an arbitrary point P whose position vector is r bar, and there is a unit vector n cap normal to this plane. First thing, we have vector OA bar parallel to unit normal vector n cap, and OA bar is in terms of distance d n cap. Secondly, AP bar is OP bar minus OA bar, that is r bar minus this d n cap. Thirdly, AP bar being in the plane perpendicular OA bar, because it is a distance vector. Also AP bar perpendicular n cap, because AP bar lies in the plane and n cap is normal unit vector. So dot product of AP bar and n cap is 0. Now AP bar is r bar minus d n cap dot n cap equals 0. R bar n cap minus d n cap square is 0, which will be r bar n cap minus d, because n cap square being square of a unit vector will be 1, equals 0, and that gives us r bar dot n cap equals d, which is normal form of vector equation. Find the distance of plane r bar dot 6i cap minus 3j cap minus 2k cap minus 1 equals 0. We can write this equation as r bar dot n bar equals 1, where n bar is in normal form of vector equation r bar dot n cap equals d, where d is distance of plane from origin. First, we will find n cap from n bar. Square root 6 square plus minus 3 square plus minus 2 square, which is mod n bar, equals 36 plus 9 plus 4. Root 49, 7. So n cap is n bar upon mod n bar, 1 upon 7 times n bar. So this vector equation becomes r bar into 1 upon 7 6i cap minus 3j cap minus 2k cap equals 1 upon 7. So distance d of the plane from origin is 1 upon 7. We have to find equation of this plane which passes through point A whose position vector is a bar. There is a vector n bar normal to this plane, and P is an arbitrary point on this plane whose position vector is r bar. Now AP bar is OP bar minus OA bar, which is r bar minus a bar. Next, normal vector n bar is perpendicular to vector AP bar because AP bar entirely lies in the plane, that is n bar perpendicular r bar minus a bar. Dot product of two perpendicular vectors is 0. R bar minus a bar dot n bar equals 0 is the vector equation of this plane. For finding Cartesian equation of a plane, consider a plane with point A on it x1, y1, z1 so that its position vector will be A bar equals x1 I cap plus y1 j cap plus z1 k cap. There is a vector normal to this plane n bar with direction ratios A, B and C so that normal vector becomes A I cap plus B j cap plus C k cap. Now P is an arbitrary point x, y, z. So its position vector r bar will be x I cap plus y j cap plus z k cap. Now we have seen vector equation of this plane to be r bar minus a bar dot n bar equals 0. Substituting the corresponding values, this becomes x I cap plus y j cap plus z k cap minus a bar, which is x1 I cap plus y1 j cap plus z1 k cap, and this whole in dot product with n bar, which is a I cap plus b j cap plus c k cap. This equals 0. This will be x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap in dot product with a I cap plus b j cap plus c k cap equals 0. Now this dot product works out to be this a times x minus x1 plus this b times y minus y1 plus this c times z minus z1 equals 0. And this is what is known as Cartesian equation. A into x minus x1 plus b into y minus y1 plus c into z minus z1 equals 0. There is one correction here. This is not y2 but y1, and this is not z3 but z1. We have to find vector and Cartesian form of the equations of a plane which is at a distance of 12 units from the origin and perpendicular to 6 I cap plus 2 j cap minus 3 k cap. Now here we have normal vector n bar equals and perpendicular distance from origin d equals 12. From n bar we find n cap n bar upon mod n bar, which is n cap is 1 upon 7 times. So we have here unit normal vector n cap. Let P be any arbitrary point on this plane x, y, z, whose position vector is r bar equals x I cap plus y j cap plus z k cap. Now vector equation of the plane is r bar dot n cap equals d, that is r bar dot equals 12, or so this is the vector equation in normal form. We can simplify this normal form and write x I cap plus y j cap plus z k cap dot 6 I cap plus 2 j cap plus 3 k cap equals 12 sevens are 84. Performing dot product of these two vectors, we get 6x plus 2y plus 3z equals 84, known as Cartesian equation of plane. We have Cartesian equation of a plane as 3x minus 4y plus 3z equals minus 8. We have to find vector equation of this plane in standard form. In this plane, we have an arbitrary point P, x, y, z, whose position vector r bar is x I cap plus y j cap plus z k cap. From the given Cartesian form, we will rewrite the Cartesian form as minus 3x plus 4y minus 3z equals 8 and extract the drs of the normal unit vector n cap as minus 3, 4, minus 3 and write the unit normal vector n cap as minus 3 I cap plus 4 j cap minus 3 k cap. Now we can write the given equation as dot minus 3 I cap plus 4 j cap minus 3 k cap equals this 8, or simply r bar dot equals 8, which is vector equation of given plane in standard form. We have to find direction cosines of the normal to the plane n bar and length of the perpendicular from origin D to the plane whose normal equation is r bar dot 3 I cap minus 4 j cap plus 12 k cap equals 5. If we consider this equation as r bar dot n bar equals 5, then this 5 does not represent distance from the origin D, because actual normal form is r bar dot n cap equals D, where this D represents distance from origin D. So first we have to find unit vector in the direction of n bar, which in this case is 3 I cap minus 4 j cap plus 12 k cap. N cap will be n bar upon square root 3 square plus minus 4 square plus 12 square, which is 1 upon square root of 169, that is 13. 3 I cap minus 4 j cap plus 12 k cap. Now we write this equation 1 dividing throughout by 13. So this will be r bar dot 3 upon 13 I cap minus 4 upon 13 j cap plus 12 upon 13 k cap equals this 5 upon 13. Now this 5 upon 13 represents distance of plane from origin, and direction cosines of the normal vector n bar are 3 upon 13 minus 4 upon 13 12 upon 13. This is a plane perpendicular to a normal vector n bar and passes through a point A whose position vector is a bar. Now for an arbitrary point P with position vector r bar, vector AP bar will be perpendicular to normal vector n bar, because vector AP bar lies entirely in the plane. So therefore their dot product AP bar dot n bar will be 0, but AP bar is nothing but OP bar, that is r bar, minus OA bar, that is A bar, dot n bar equals 0. That implies r bar dot n bar minus A bar dot n bar equals 0, or r bar dot n bar equals A bar dot n bar. So this will be the equation of a plane perpendicular to a vector n bar and passing through a given point A. Find vector equation and Cartesian equation of a plane passing through the point with position vector a bar 4 I cap plus 2 j cap minus 3 k cap, and it is normal to a vector 2 I cap minus j cap plus k cap. If P is any arbitrary point with position vector r bar x I cap plus y j cap plus z k cap, then equation of this plane is r bar minus a bar dot n bar equals 0, that is r bar dot n bar equals a bar dot n bar, which will be r bar dot 2 I cap minus j cap plus k cap equals 4 I cap plus 2 j cap minus 3 k cap dot 2 I cap minus j cap plus k cap. This will be r bar dot 2 I cap minus j cap plus k cap equals dot product of these two vectors, 4 2s are 8, minus 2 minus 3, that will be 3, and substituting the value of r bar equals 3 after dot product, this works out to be 2x minus y plus z equals 3, which is the Cartesian equation in the standard form. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. See you in the next video. Until then, keep watching Number Collage. Thank you.